Hello everyone, this is an RC circuit with a power supply, DC power supply. The switch is closed at time 0, a voltage probe is connected across the capacitor, and this is the reading of the voltage across the capacitor. Clearly the capacitor is charging. Okay, the first question, what's the EMF of the battery? We know that when the capacitor becomes fully charged, then the voltage of the capacitor will reach the same as the voltage of the battery. That's clearly the maximum voltage reached by the capacitor. So we draw this horizontal line and we see that the maximum voltage reached by the capacitor is 6 volts. So this is the EMF of the battery, 6 volts. Part B, what's the time constant? We know that after one time constant, the voltage of the capacitor will be 63% of the maximum voltage, which is the voltage of the battery. That's the maximum voltage it can reach, which is 0.63 multiplied by 6 volts, the EMF, and we'll get around 3.78 or 3.8 volts. That's the voltage of the capacitor at one time constant. Now, to see what's the value of that time, we go to the graph, we see where is the 3.8. So we have 1, 2, 3, this is 4, so 3.8, it's almost here. So if we draw this line and we see where it intersects with the graph, clearly it intersects at time equal 5. So this means the time equal 5 is the time constant. So the time constant is 5 seconds. What's the value of the resistance R? Now, we know by definition, the time constant is R multiplied by C. So this means 5 is equal to the resistance multiplied by the capacitance is 500 microfarads. 500 times 10 negative 6. You do the math, 5 over 500 times 10 negative 6, and you will get 10,000 ohms or 10 kilo ohms. So that's the value of the resistance, which is 10 kilo ohms. Finally, what's the voltage across the resistor after 3.5 seconds? Remember, this is the voltage, the graph of the voltage of the capacitor, not resistor, but we are going to use it also to find the voltage of the resistor. So after 3.5 seconds, we come here and we see where is the 3.5 seconds. This is 1 second, 2 seconds, 3. So 3.5 almost here, somewhere here in the middle. So we draw this line. You can see where it intersects with the graph. And we draw this line, the horizontal line, to see what is its value. So the voltage of the capacitor at 3.5 seconds is 123 volts. So that's the voltage across the capacitor after 3 seconds. So the voltage of the capacitor after 3.5 seconds is 3 volts from the graph. The voltage of the resistor, if I use Kirchhoff here again, so if you use Kirchhoff, that's the battery, the resistor, the capacitor, okay, R and C. So if you take a starting point and you go this direction, so you will have the EMF minus the voltage of the resistor minus the voltage of the capacitor. It will give you 0. So the EMF is 6 volt minus the voltage of the resistor minus the voltage of the capacitor. We have found it as 3 volts. So this means voltage of the resistor, it's 6 minus 3, so we're going to get 3 volts. So also the resistor has a voltage of 3 volts at that time. Thank you.